Good morning. Underlying file. So, I have a bug. I've been able to isolate it. Well, turn it on and off. I can turn it on and off by enabling the wall log in my VFS or not. Right? Basically, these pieces here, I suspect that there's an issue with how I'm sharing the information. It might be due to zname not. It might have to do with zname. Um, Let me explain what I'm seeing. So, the gauntlet tests, I have two threads on the left test runner. These are only the left test runner that we're using. We have thread 1 and thread 2. Okay. We load the VFS. If we do not load the VFS, the problem doesn't happen. Let's verify this. Okay. Problem is fine. We just get some debugging information. Let's validate this. We should see close start and close exit twice. Once and twice. Okay. Exit, exit. Great. So let's make some quick notes. Only happens when VFS is loaded. Happens during shutdown. Let's verify that. It should not complete this here. So 2 and then A. We will never see A. Okay. We see the logging. We see 2. We never see A. We see DB close start, but no DB close end. Okay. Second close of the DB connection never returns. I have also traced that into some of the test utils. Oh, nope. Where's it? Bin gauntlet, close. We never get an error. It just doesn't return. Okay, so why doesn't it return? Here's my notes. Here's my notes. Will not happen. Let's see. If all log specialization is disabled, will that happen? And that is in VFS. Here. Essentially, if I tell it not to come through and process the wall log, but instead make the wall logs pass through, it won't happen. Okay. So, wall log specialization still causes an issue. It is not related to shutdown or wall close. Returning early does not fix it. Bug notes. Let's verify that again. So here we return early. Everything here is wired up. Yes, good. It doesn't return. Okay. So something is interesting, and we do have. Oh, and if we look at what's going on with the logs, um, the way that the test works, and maybe we should look at the test first so you understand that. We load the VFS. We open and set the journal mode on thread 1. Thread 2, we just open these. Now, none of this happens concurrently. It all happens serially. We wait for an acknowledgement that each piece here happens. Hey Sam, how are you? We're going on a bear hunt, bug hunt. We're gonna catch a big one. What a beautiful day. Oh, man. Happy Friday. I gotta check something real quick. Let me adjust something quick. I need to text a friend. I can just propose a new time. Okay. All right. Thank you. All right. Yeah, I try to stay in contact with people I've worked with, and today I needed to move my lunch meeting. So we chat with a friend. Okay. So we open, we initialize. This creates some data, right? On thread one. On thread two, we also create some data. Then we close them. In order, reverse order doesn't matter. Now, if we omit this writing on thread two, the test passes. Okay. Now, why is that though? So we should be getting two closes. There's one close, and where's the other close? Do we only get one close? Do we not open the second one? There's one, two. There's the main DB opening. There's the wall opening. And yeah, it just doesn't open the second file, which is fascinating, right? Like we tell it to open it second time. Maybe I only looked at the second one. Let's keep going back. Okay. Nope. That was my mistake. One. Right. There's the main DB. I tried to open a journal. What? Oh, wait, did we? Why would it try to open a journal file? That's weird. Oh, because of our previous test, we got to clean up. What was it? Gauntlet, Rena. Oh, did it already clean up? Because it passed. Oh, beautiful. Okay. One more time. This time with extra. Okay, go to the top and we'll follow it all the way down. Initializing. Okay, thread message. Load the VFS. For right and left. Great. We're only using left. Open the DB. On thread 1. Thread 1 opens the DB. Set the wall log. Okay. It checks for journals. And it opens a journal file. What? No. No. Why is it opening a journal file? Did I comment out something? That is saved. Okay, we know the VFS is loading, but why is it only going into wall mode? We have true, load with VFS. Like, this actually has to be true because we loaded the VFS. It's actually an error to do that a different way there. Open. IO methods, proxy file, IO methods. Okay, passing it through to the right place. But why? Okay, why are we getting journal mode? And here we're salting. Wait, what? Here we open a wall log. All right, maybe it just loaded that file first for some reason. So at some point we set the mode to wall. So maybe it's trying to load the journal file to draw all the data back in. No idea. That sounds good though. We delete the journal. Okay, so that must have been it. We're converting the modes. So then here we open it a second time. Okay. Nope. No panic. No panic yet. Okay. In it, we create some data. We open the wall log. Make some changes. Salt it. Salt it. That's a notify change. Notify change. So we get some changes to the pages. Then we try to close. Where was our message to close? It's not here. Oh, wait, there it is. Okay, 0, 1. We close one of them. Main DB. Now, in this case, we should only get a log line. Start to pull data back from. So what's going on here? We're doing some reads and writes. So reads from the wall log, writes to the main DB. And we delete the wall log. That should have resulted in a rotation. Why did it work? This should not be working. Oh, wait a minute. Because here we're returning early. Huh. Okay, I'm glad I went over this because last night when I was doing the same debugging, I did not notice this, that if we return early, everything works. Okay, this is not correct. I want to validate that. Now, the reason we're not seeing the rotation is because we have basically the code is bypassed. Okay, let's try again. Cargo build. This should break. It should break. Hmm. Result true. We shut down twice. Okay, that's bothersome. Again, I want to run it a couple times, see if. What? Okay. Well, it appears to be working. Why? Did I disable something else? No. Are they each. No, they're not getting their own wall state. Hmm. I am surprised. Also, this is never false. We don't see that getting called. Okay, just to validate, this is the section where we are making changes. We are asked to close the file. Yes. So we're closing that. Main DB. Okay, we synchronize the wall. Start to read pages back into the main database. We're going to truncate back to a size, 2 pages. Close the file. Delete the wall log after we rolled it. Fine. And then we close it. No, that's the main DB. Then we're told to close it a second time. Oh, it never finishes. Oh, I'm incorrect. It does. Why? Why does this work? And why didn't it work last night? Hmm. So I know of some other bug that I found last night. Quite frankly, could just be due to the memory, some use after free, and that at the moment it's lining up correctly. Yesterday it wasn't. If I do this enough, it might start failing. Oh, look, it failed. Really? Wait, why? Oh, because I hit tilde. Everything's passing. Okay. Well, let's go into what I found last night. And I want to check something. I just want to make sure. Yeah, just some logging. Some corrections to the acknowledgements. Thread ID. Oh, that's right. I added these try reads. So I wanted it to error out. Try read and try write. Let's let's change that out. Because that is different. And the drop. Oh, the drop impl. Drop does nothing at the moment, but I think I might want it to do something else. Okay. Try read. Let's put this back. Okay. Small changes. Okay. Still passes. All right. The other one was a drop on wall shared state. Okay. Now, it dawned on me last night that this is incorrect, the way that wall close is implemented. We close the underlying file after after the first um, the first time it's closed. It should be closed when the last reference to it has been removed. Okay. Now, there's also another bug that goes along with that. In that, here, I even if I was using args across, well, even if I was, whatever, I don't know what I'm trying to say. But because I have an arg in a hash map, we would never get rid of it. The hash map owns an instance of it. So we were leaving data around. Okay, so two problems. Memory leak. This never goes away, never shuts down properly, right? Because it should be the last one shuts it down, not the first one. And then there is a subtle bug that I saw while digging through all of this, which had to do with, oh, where is it? Ah, it's over in lib, I believe. No, file. I think it's in init. Post init, no. Oh, here. Okay. Xopen. Basically, when SQLite calls us, they have certain guarantees. One of those guarantees is that the pointer to the name is valid until xclose is called. And at the moment, because the first call to xopen to us basically sets up this pointer that we keep around. After it's closed the first time, this pointer is not valid anymore. So we need to have our own copy of that we can manage the lifetime of. So 3 bugs. Issues 1. Name or pointer to the file name is uh, is incorrect. Treating it as valid to the second call to xclose. Okay. Second issue. Third issue. What is the third issue? Third issue. I think it's very closely related to the first one. File name is incorrect. Oh yes, yes. The wall shared state should be valid until the last call to wall close happens. Okay. I like it. Now, what I've been thinking about that would solve some of these issues, hopefully all of them, is by getting rid of, let's see, of this wall state here and changing what it looks like. The idea is to have something like a new wall states once locked to. Does it need to be a mutex? Synchronization happens to all of our mutations in SQLite, so we don't have to worry about that. But so once locked to a vector of shared wall state or wall shared state. Okay. Now, what we would do is have an index into that. Bar, let's see, name to slot. And this would be a hash map that basically looks up which position in the vector your files are located in. So similar to this here. And in this case, we need a mutex because multiple files can be opened at the same time, but they will not be mutated at the same time. Hash map to C string to usize. Name to, I don't like slot. Let's call something else. File name to wall slot. Huh. Okay. So we open a file. We lock on this file name to wall slot while we are setting up the new wall states. So we will need to ensure that we're always locking on this when we are adding or removing from new wall slots. Let's log on. Okay, so maybe these should be part of something else, right? Maybe we have some new structure and we hide this sort of complexity behind an interface. Struct. Wall state. Struct. Global wall states. If you want to be able to get something out of here, fine, we'll do that. But if you want to add or remove to it, you've got to lock on the mutex. Okay. Let's see, this is internal, so we'll say name to slot because we know what it is. Text to a hash map of C string to usize. And then we would have states. Shared states. Okay. Derive, debug, and default. Okay. I like that better. New wall states will be a once lock to this. Global wall states. Maps a sqlite file name to a slot to a state. And then what we would do is we would just give um, we would give each connection basically a number, the use size that points to shared states, so they can read from it willy-nilly. If they need to close, we would lock, ensure that we're shutting everything down correctly. If we need to open, we do the same thing. We lock, make sure we're setting everything up correctly. Like that, we have new wall states, getting rid of wall states. I don't want to break all of that yet. So we're going to leave this as new wall states. Araga, how are you? ¿Cómo se va? ¿Sabe bien? I am not very good at Spanish at all. So I did happen to grow up in Southern California, so I picked up some interesting tidbits, but nothing that's really, I don't know, usable. I could order a hamburger with onion or not. Doing some stuff that requires low attention, which means you have time to join us. Nice. So global wall states. Yeah, I want to start to change this. So shared wall state. We need a valid pointer to a string for this, right? That's the other issue we found was that the pointer to that data must live for so long. Hmm. There might be one issue with this in that one of the other APIs for SQLite, it lets you basically convert between the different file names, So if you go from the main DB to the wall log to these other things, it actually does a very quick lookup. Should still work. As long as I can ask for food, I can survive. Food and beer. Um, that's all I know how to ask for, really. I also know how to say I'm sorry, which is very useful. Um, File name, and this would be owned, so we'd have a C string. I also want to get rid of this and change it with a reference count. Um, let's see. Hmm. We could manually use, let's say, so we can say as pointer, which gives us a pointer that we could save, right? And using this pointer there, we could decrement or increment the strong count. Maybe not, though. I don't like that. Okay. Ref count. Atomic int. Atomic. I don't know. It doesn't need to be very big. How many threads can you have on a box? Atomic U32. There we go. But we could probably make this smaller, do like a 16. But I don't think it's going to help us with our atomics. I just can't see us ever having that many connections to a box. Or to a file. 65,000. That seems reasonable. Yeah. All right. So we'll have a reference count so we know when to basically clean this up and call close on this. Nice. Okay. So where do we start? We've made a couple of big changes. We could let the compiler guide us and comment this out. Let's do that. That's gone, yes. And ref count is atomic U16. I don't know if we want that as 0 or 1 when we start out. And we want the file name, yes. File name. What do we have available? We have Z name. Something like that. And Z name. Oh, we could pass that in. C string file name. To own. And we'll just C string. Ah, there we go. Set file closing. In this case, this is going to move. No more drop impl. Hmm. Okay. So what do we do when we get a new element? Right? We get the new wall states. Right? But we're just going to get the object, and then we're going to have the object do most of this here. Save. And this, let's just call it wall states. Import. That's right. There's no more lock here. Lock is internal. It always exists. Okay. All states dot. And at this point, we just want to call a function that essentially does all this stuff and returns us a wall state. Get or create wall state. Ooh, that's horrible. Um, it's kind of like an upsert. Find or create. Now we are going to find it by its entry. So let's pass in this C string file name. It will also need this information. Can we set it up so that it always has a reverb? Maybe. Yeah, let's do that. So we have the name. We need the flags. Out flags? What? We don't need out flags. What do we need out flags for? And the underlying file. Basically, we'll do that. It will not do this. We call this shared wall state. Okay. Create that. Thank you. I have to save all files for that error to go away. So we get the states, find our create. This basically goes over there. Something like that. Now, we also want a reference to reverb, which we have here. This is in this little jail cell so that it can be shut down. Oh, this is going to whine at us because. Okay. Let's pass reverb in as well. What we have for reverb says X open. Reverb here. It's a mutable pointer. Do we convert that file, underlying file, reverb file? Okay, it looks like we're passing in the mutable pointer to reverb. Oh, we just want the ID, don't we? Shared state or whatever error. What are we using for errors around here? This error? Okay. It's actually not to create this error. Um, it's the one that was under the cursor. Yeah, we'll just leave to do there. Okay. And then later, when somebody needs to get one of these, we can return a mutable reference to it. They'll give us the position and so forth. Okay. We need a mutable reference to solve. We're going to lock on name to slot. Let's remit our plan out. First thing we do is self.name to slot.right, dot lock. Uh, yeah, that's a reference to that. We'll drop it at the end. Unwarp. Oh, nope. Let's try searching again. Yeah. Dot entry. And we want the file name. So now we have an entry. It's occupied or vacant. Okay. If it's occupied, then we should just return the value because that's a map to the one we're looking for. Really? Thank you. Okay. Now for the more interesting piece where we have to find an empty spot and then create one, then store the value here. Oh, this should be an option to something. Okay. First empty slot. Then we will create a new shared state. Store shared state in slot. Return slot. Okay. So first, self dot shared states dot iter. Want to find a position, so we want position, and we take a predicate. Now, in this case, we're going to use option is none as our predicate. Now, does this return an option? By default, it does. Slot is equal to match. Oh, can we even do that? I don't think we can do that. Let's see. Push a none to the end, and then return the length of it. -1. I think this is correct, isn't it? Let's see. If we had nothing in there, and then we push something on, the length would be 1, but we need it to be slot 0. Okay, that's correct. Create the shared state. Here we can just return slot. And which is a bit of this here. In its underlying file. We're calling X open. Let's go ahead and move this. This whole thing needs to be reorganized. So, cannot find that. Import it. Logborn. Okay. 5 args. The name. So this would be file name dot. Oh, this has to be one that exists for the lifetime, which would be a pointer into the hash map. Okay. I actually want pointer to this one. Warning. Huh. Doesn't give us a warning. flags. We pass that through. Out flags. I don't have an out flags. Out flags is equal to, I don't know, what is it? 0. It's mutable. As that. Oh, and mute. Reverb and underlying file. Okay. Now this will return a result. Hmm. What if our result is not good? I want a different type for this as well. While state slot, use size. And these are copy and clone. Okay. Oh, and we have to save that store. So in the entry, so the other direction. What was I doing before? Huh. And we can get rid of the file name here, because that's actually stored in the hash map. I do want the ref count though. Um, underlying file and the flags. Okay. It's just called flags. Entry dot insert. Value is slot. Okay. We're missing error handling here. Maybe we do this earlier here and return before we start to mutate things if an error happens. Something. So bail early if we can't make it. Otherwise, find the first empty position. Save the rest. All right. New wall states. You are once locked to global wall states. Okay. Okay. Now, oh, that moved. That makes sense. Did I change the... I forgot that this is used by the others as well. Um, no, I think we're still okay. Okay. So we get the wall states, find one. If this is an error, see, we don't handle it here either. So arguably, we should be doing what? So if it's not equal to okay, we do this, but only after this has been set up. Saying that we create this anyways, that we return something that looks like it's valid. So state is set. That should be like a sum or a none. It should be an error or a state. Let's turn that into an error. So here, let's rename this. Underlying file init error. And, oh, you know what? Let's just return that in from this. Here we go. Paren is missing. Got it. Got it. So that changed. Good. So now that's a result. Love it. Which also means that if that's a result, we can bail early. We no longer have to do that ourselves. Result is not used. That's fine. Okay. That looks good. So here, basically, we want to now map and convert this into a wall state. Okay. just call it state. Mismatched types. Ah, yes. Now it just has a number. The state is a wall state slot. Let's be more explicit with that. Shared wall state. Hmm. Oops. Slot. Got it. Good. It's fine. Yes, now all of these are broken. Which is perfect. Okay. Oh, we could impl methods on wall state slot and it could reference the global bits. Oh, I like it. Okay. Underlying file self dot slot. That needs to be renamed. It needs to be like shared state slot or something more interesting. Let's just call it shared state because this. So we have wall shared state. Why don't we just call this? I'm going to call it wall state. Oh, no, we can't. Okay. Whatever. Naming is hard. We'll come back to that. Oh, did I do that? So wall state slot. Okay. And what would this look like? So let's say we wanted to get the underlying file. Underlying file. Great. We have some method. And we will say we want new wall states. So we take the new wall states, we get that, so to unwrap. Interesting. Do we need this for anyhow? Global wall states dot shared states self dot zero dot what's this return? So now we have our global shared state. And well, shared state has an underlying file in it. Why don't we see that though? Ah, because this is an option. That's right. That's more of an expect. Expect. Cannot move out of that. Because in this case, we just need a reference to it. And here we end up cloning it because that's a copy value. Copy. Okay. A little bit of proxying. Don't know how I like that. Here it looks fairly clean. All right. Let's see what else we have. Handful of those. Wall state is defined multiple times. No. Where's the other one? Wall state. I only see one. This is wall shared state? No. Hmm. It must be imported. Here. There we go. Okay, so let's do the same sort of thing. Seasoning is changing. What? Yeah. Something like that. Shared state. Probably want to replace salt. Something like that. Inline macro. Generate. All right. So replace salt. We need a mutable reference to self. Let's extract this into a function. Hey, Slim JD. This is not NeoVim. This is actually an editor called Helix. And in order to get it to wrap like that, um, so we basically set the end of line diagnostics and warnings here. The rest is pretty much default, right? Just a couple little modifications. Oh, you're welcome. Okay. Now this is, let's call it slot ref, or ref slot. I think we're going to need a mutable reference to a slot. Cannot borrow. What? Hmm. But it's global, and I know it's okay. Um, so what about, so cell's interesting. We're actually using a one cell at the moment. Unless you have a mutable reference to the one cell. Oh. Um, okay. Not borrow a mutable static item. Boo. Okay. Yeah. So basically, when you're creating it, Okay. The issue I'm having is that any sort of mutation to a wall log would only ever happen in one thread, and this is guaranteed by SQLite. So, how do we avoid double locking? I mean, it should be cheap, right? Because it's basically guaranteeing that there won't be contention. So maybe a mutex would be really fast because there is no contention. But why pay the price if you don't need to? I would really rather not have to lock whenever I need any of this data. We know when we have to lock. I don't want a once lock. I want a global cell. Failed to resolve use of states plural and is not constant functions. Okay. Let's create a new, generate new function. New is const pub function new, or pub constant. This is a mutex to a hash map. I'm just checking to see if everything is const-ish. Yeah, that is. And shared states. Oh, one argument. Um, hash map. Okay. Fine. Oh shoot. I'm late. I've got to go. All right. I gotta put this away till later. So we're going to raid and run. All right, y'all. Happy Friday. Have a great weekend. Take care.